interpret your numerical data, by virtue of which you can understand, okay, my research is working, or okay, my research is not working. Fine. The second objective of statistical data analysis is to collect sufficient evidence about various parameters or components of a technology. Look, whenever you're doing research on a technology or on any of the sciences, you have decided some parameters. Maybe example, you are working to enhance the efficiency. Maybe example, you're working to reduce the time. Maybe example, in case of components, you want some component to be speed up. Like for computers, you want to be processors to be more speed up, isn't it? Now, what statistical analysis is going to do, it is going to provide you the evidence that whatever you have thought about your research, whether you achieved it or not. For example, I am giving you, let us consider already existing dual core machines were existing. Okay. Now you are doing the research to speed up this dual core machines into the i3 machines, i5 machines, i7 machines. So whatever the number of instruction getting processed by i3, i5, i7 will tell you that whether you are faster than dual core or not. So this statistical analysis is going to give you evidence that whether your parameters or components of a technology has really enhanced or not. The third objective is to compare the quantities obtained from current system with already existing system. Very, very important point. I want all the researchers to focus on this point. Quantitative analysis will give you a comparative study. Comparative study of what? Comparative study of your results and existing results. So by virtue of this comparison only, you can conclude that, okay, my system is better than existing system, or my system is lower than existing system, or my system is parallel to the existing system. And who is going to help you to decide that? It is quantitative analysis, quantitative statistical analysis, which is going to give you this leverage, this luxury, which is going to give you comparison between the existing system and the current system. Then the last objective is to provide conclusive remarks. Now, what about providing conclusive remarks? Look, after your research, you need to conclude somewhere that, okay, this was my objective of the research. This is what I've achieved. Now, to say this, what you have achieved, you need quantitative statistical analysis. You can claim that your research is better or not better upon some numbers, and these numbers privileges are going to give by quantitative statistical analysis to you. Now here are statistical measures, how you can perform quantitative statistical analysis. These are some examples which I quoted for your understanding. I hope everybody is going to belonging to science and technical field, so you can understand these keywords easily. And these are some examples by virtue of which I make you understand that how you can perform this statistical analysis. So the first keyword is mean, then there's a mod, then median, then standard deviation, then quantization error. So I'll explain each of them in detail. So next slide, please, about mean. Yeah. So what is mean? Mean is sum of all the data values divided by the total number of data values. So mathematically, it is given as capital M is a summation of small x divided by capital N. Now, X is the data values and N is the complete data values. So whatever the value we'll get is capital M, which is mean. Now, where it is utilized, technically it is utilized in image processing. There is a domain in computer science and engineering or software engineering, which is called as image processing. For image processing, the mean is utilized. Now, you might be wondering that what is the application of obtaining mean? Look, if you are using color images, which is working in RGB model, red, green, blue model. And if you're trying to get the actual data into it, because the pixels which are belonging to an image will range from 0 to 255. This is the range in which those pixel values used to belong. So if you want to get the meaning of the image, that how much meaning that image carries, that meaning can be determined by using mean function. The technical term which is utilized is called as image entropy. So if you want to determine image entropy, you need to have this parameter mean to it. And if you determine mean, you can conclude that what is the image entropy, which is belonging to an arbitrary image, which you are processing. Next. The next is mod. Now, what is mod? Try to understand. This is another technical keyword associated to mathematics and computations. Mod of a set of data values is the value that appears most often. Now, you might have seen Taylor series, Maclaurin series, arithmetic series, and other series are there. Now, what happens due to that? If a certain number in a series occurs again and again, so what you start analyzing out of it, what you start interpreting out of it, then what is the repetitive value which is appearing again and again. I can fetch that repetitive value, and this repetitive value will represent the entire series, maybe with some errors, permissible errors, negligible errors. So to determine that, you need mod. For example, where you can utilize the things like mod, say like if you have a big array of the values, and if you want to represent that big array of the values in some single value only, so what you will determine, you will try to search out the value which is repetitively occurring in that sequence. So you will pick up that value and say that entire set of these values will be represented by one single value. Why? Because it is repeating again and again. So that value is the mod of that particular larger matrix or larger set of values. So this is how statistical analysis of mod can help you while representing multiple values in a single value. I quoted an example. If you can see a series, I have given 1, 2, 2, 3, 4, 7, 9. So if you can see 2, 2 is oftenly repetitive over here. So you can say 2 is the mod of this particular series which is available. And you need this sort of analysis while doing your research. Next. Yeah, then you're having median. Now to obtain median is also the need of various research analyses, statistical analyses. What is median? Median is the value separating the higher half and lower half of the data samples, a population or a probability distribution. Look, there are various operations when you're doing research where you need to divide the set of values in two parts. The first is the left part and next is the right part, or sometimes you need to divide in the lower half and the upper half, like that. If you are aware about some algorithms like binary search algorithms where we need to divide the list in two, isn't it, to obtain the median? Or whenever you are searching the word into the dictionary, so you need to open the dictionary in a way that you will get the word properly. Or you might be searching a number into the telephone dictionary, so you need to open the telephone dictionary accordingly so that you will find it. So median is also important while performing various statistical analysis or data analysis to find the mid of the series. And if you find the mid of the series, then your searching or sorting becomes very easy for various numbers or series of the numbers which you have gathered or which you have collected as a research outcome. Next. Then standard deviation, which is again important thing to look out for. Standard deviation is a measure that is used to quantify the amount of variation of a set of data values. Look, if you want to determine what is the difference between the two data values which I got, now to determine the difference, you need to operate standard deviation. Now, how standard deviations can be evaluated mathematically? It can be mathematically given as square root of summation of xi minus xn. Now, xi and xn are the two arbitrary variables. Square of that and divided by small n, which is the total quantity or the set of the values which are belonging to a unique set or a obtained set. So standard deviation. For example, if you suppose if you want to determine that whether suppose you got the X-ray of a skull, and you want to determine that whether that skull is carrying any sort of unwanted organ into it, or sort of unwanted development into it. So what you will do is that you will observe the difference between the two pixel values, and those two pixel values can evaluate that what is the difference into the image which is occurring. And by virtue of that, you can start interpreting that there is something wrong into the skull. So this is how standard deviation will help you. Next. Then quantization error, so very important statistical analysis parameter. Now what quantization error will give you? the difference between the input value and its quantized value, which is called as quantization error. I will simplify this and make you understand that what is quantization error. The quantization error also introduces noise or quantized noise to the sample signal. Now let us understand what is quantization error. Let us consider you all are working in various organizations, so you might be using biometric, thumb to mark your attendance. Now let us consider that when you are inputting your biometric, your thumb was completely dry. It is giving good signs of your all the images which are driven on your thumb. So that thumb, when you're giving as an input to the biometric, that get recorded, and tomorrow morning when you're coming to the office, you're again giving thumb. But unfortunately now it is raining when you came to the office. Now your thumb becomes wet. So whatever the prints you require to input into the biometric, it is not giving. So that biometrics stops identifying you. It will not identify you as an individual who has given the thumb yesterday. However, you are the same individual. Now, this is called as quantization error. Even though you are same, but whatever the input you are giving is not pure, is not correct up to the mark. It is having error into it. Now, you need to design the systems which should have the permissible quantization error. Now, what is permissible quantization error? Understand this. I am giving the input of my thumb when my thumb is dry, and tomorrow my thumb is wet. Now I should give some permissible error into it, say like up to 60%, up to 70%. If my thumb is matching, it should allow me as an employee, it should mark my attendance. So this is called as permissible quantization error. Are you getting it? So this is quantization error, which is so very helpful to us while doing the statistical analysis. And if we are using it, we can reach to some conclusion, we can reach to some evidence which we are searching out of the research. Next, please. Yeah, now how to perform some quantization error graphically. So I can propose you some of the generalized tool, because I consider that all the people which are belonging to this session are belonging to various fields like science and engineering or technology or some other fields as well. So I'm giving a simple tool of Python, and I given the URL as well. You can go to this URL, and by virtue of this URL, you can get the online compiler associated to the Python. It is so very simple language. You can get accustomed to this language in 1 week's time or 4 days time. So what I've done is that I introduced a library, I imported a library, and I created a PLT variable of that library PLT. And then I am passing two parameters. One is year and next is population. So this year is having the range of years from 1990 to 1995. And then there is a population which is growing according to the years. And I'm putting a function saying plot, plt.plot, a graph between year and population. And whatever the graph have been plotted, simply show that graph. So once I put this function show, it will show you the output. Next slide. So simply this is the plot of the graph. Now it's an example which I'm giving. It's a very simple example. What is interesting into it, try to understand it. Now what I'm doing is that I'm giving you the analysis of how the population is rising onto the y-axis according to the years which are exceeding into the x-axis. So this is the plot of the graph by virtue of which you can prove that look how the population can grown up, advanced by virtue of the years. So this is how statistical analysis becomes evident. As I told you that you need to have some evidential analysis while proving your research, and here by virtue of this diagrammatic presentation you can prove your research that look when the year is 1991, what was the population? When the year is 1992, what was the population? So this is the plot of the graph which will accomplish your research task. Next. This is another example. Last time I given the example of Python. This is the example of Matlab. You can even use Skylab. There's no problem. Skylab is a freeware. Another URL I given. You can use this URL and you can plot your graphs when you're done with your research. And I given some coordinates X, Y, Z, and there are some peak value which I given. And I asked you, I asked the Octave Online to plot a graph for that. and look the surface which I have given by this site to me as an output. Can you go to the next slide, please? This is the plot of the graph, which will give you the clear-cut statistical analysis of X, Y, Z coordinates, that if these are the random values, then what are the values of the waveforms? So this will prove your research. This will give sufficient evidence and conclusive remarks about your research, that what will be happening about the varying quantities and varying parameters. Next, please. So this is it from my side. Thank you very much. I again repeat the sentence, which is the rule of thumb in the quantitative statistical analysis: collect the data properly, interpret it properly, and publish it properly. This is so very important. Collect it properly because all the operations are going to depend upon your collected input. Interpret, get the meaning from some method